Hi guys, let's take a look at this question where we have a 2 kg block that is initially at rest at point A. So it comes from this point, right? Which means initial velocity is 0. At the bottom of a rough incline, so there's going to be some sort of friction there. And the block is pulled up by the incline by a constant force F acting parallel to the incline. The block reaches point B, which is at 4.5 meters above the horizontal with a speed of 2.25 meters. So at point B, the speed is 2.25 meters per second. So 5.1, define the term non-conservative force. If you've been watching my videos, I've probably said this like 100 times. So a force is non-conservative if the work done by the force of an object depends on the path taken. 5.2, draw a labeled free body diagram for the block when it is pulled up the inclined plane. Okay, so it's 4 marks. They probably want 4 forces. Right, so 5.2, they want a free body diagram, so I'm going to draw my dot. So just imagine that. So let's first draw it on the diagram so you can actually see what I'm talking about. So they already drew the one force for you, which is the constant force F acting parallel to the incline. They said it's a rough incline, so there's going to be some friction, which is going to be smaller than the constant force. It's up an incline, so it's going to be some gravity. Gravity is always acting on it, right? And then the normal force that is perpendicular to the surface. And that is essentially a free body diagram. So I'm just going to jot it down on here as well so you can see how it looks like. And that is perpendicular. And that's 4 marks, done and dusted. 5.3, calculate the total work done on the block by the non-conservative forces when the block moved from point A to point B. So from this point to that point, calculate the total work done. So I'm going to write it down here. So I'm just going to show you the formula that I'm going to use. I'm going to use this formula, the total work done. Whoopsie. Kinetic plus potential. So that's going to be final velocity minus initial velocity. Final height minus initial height, because remember we're working with 2 points, A and B. So the mass of the block is 12 kgs. The final velocity would be at point B, right? So that's going to be 2.25, because remember they said that at point B the speed is 2.25. Oopsie, sorry guys. So 2.25 minus initial velocity. It comes from point A, which was at rest. So that's going to be 0 squared. And again, mass is 12. Gravitational is constant, 9.8. And then the height. At point B, it is at 4.5. And at point A, it's literally 0. So final is 4.5 and initial is 0. So then you put that all into your calculator and you will get a total work done on the block by the non-conservative forces to be 559.58 joules. And that is it, guys. See ya.